A function is a special relationship where each input has a single output. Okay, I'm going to go ahead and underline input in blue, and then I'm going to underline output in red. And the reason why I'm doing that is because these are really important terms. We'll start with an input. So what is an input? Well, when you hear the word input, it has in it. So it's obviously something that's going in. Okay? So it's what's going into our function. So the input is also known as our x-coordinate. Okay? So what's going in? The output has the term out in it. So that means that's what's going out. So once the input goes into the function, the output is what you get in return, which is your y-coordinate. For example, we have a set of ordered pairs, 3 and 8, right? Our input would be our x-coordinate, which is 3, and I'm going to go ahead and circle that in blue. And our output would be our y-coordinate, which is 8. Okay? So basically what that means is a function is a special relationship where each input has only one single output. So the input of 3 only has an output of 8. Functions can be demonstrated in 4 different ways. Okay? The 4 ways that a function can be demonstrated. The first one is an ordered pair. Okay. The second way that a function can be demonstrated is through what we call a map. The third way that a function can be demonstrated is through a table. And then the fourth way is a graph. Okay, each of these functions have an input and an output. So what I'm going to do is I'm going to start with my ordered pairs. Okay, so I'll start with ordered pairs. Okay, ordered pairs are just the points that go on a graph, the coordinate points that go on a graph. So ordered pairs, so let's say we have a set of ordered pairs. So we have, I'm going to use 3, 8 again. We have 5, 7. We've got 1, 2. Oops, that's supposed to be a parentheses there at the end. So we've got our ordered pairs. Okay, and how do we know that this is a function? We know it's a function because according to the definition, there is one, or each input has one single output. So 3 can only go with 8, 5 can only go with 7, and 1 can go with 2. So we can say, yes, this is a function because there is one input, there's one output for each input. What if we had the following example? Let's say we did 0, 4. Then we had 1, 3. And then we had 1, 7. Okay, so now we have a set of ordered pairs. We're going to look at all of our inputs. If you see here, we have an input of 0, an input of 1, and an input of 1. But if you look at your outputs, 0 goes with 4, but then 1 goes with 3, and then here it goes with 7. This is not a function because you cannot have repeating outputs for the same input. So you cannot have, you cannot have different outputs for the same input. Okay, So this is ordered pairs being represented as a function. The second is called a map. A map so a map looks like this, where you have 1, 2 columns, and then rather than writing it as a set, we're gonna write all of our X's on one side and all of our Y's on the other. So all of our inputs on one side and all of our outputs are gonna go here. So let's say we have inputs 1, 2, 3, 4, and then we have an output 5, 6, 7, 8. So how do we know which input goes with what output? We're actually going to be using arrows to indicate that they are a set, okay? And so we know that this is a function because once again, each input has its own output. But what if we were to have this example? What if this were a 2? If this were a 2, we would have 1 and 5, 2 and 6, but then here we would have 2 and 7. So you've got the same input, but with 2 different outputs, and that is a no-go. So that means this is not a function, okay? Not a function. So that is a map, okay? The third we said was a table. Tables and maps are very similar in that the inputs and the outputs are separated. So this is a table. Table looks like this. You have probably done them when you're graphing. And so with the tables, you've got your X's, your inputs on one side, and you've got your outputs or your Y's on the other. And so if I were to write out all of my inputs, so let's say I've got 3, 6, -2, and 1. And then I've got the outputs 7, 4, 8, and 3. So again, in order to tell if this is a function, we have to check to see, oops, almost used the wrong marker. We have to check to see if of all our inputs have one unique output. So 3 can only go with 7, 6 can only go with 4, 2 can only go with 8, and 1 can only go with 3. What if I were to add another input here of 6, but instead I had an output of 9? Would this be a function? The answer is no. This would not be a function because you have the same input but with 2 different outputs. So not a function, okay? What if we had another example of a table? I'm gonna draw another table. So we've got our output in red and our input in blue. And let's say we had 1, 2, 3, 4, and then we have the same outputs for each one. And then we said 1 goes with 7, 2 goes with 7, 3. Is this a function? The answer is yes, it is a function because you don't have different outputs for the same input. Every input has its own output. It does not matter if the outputs repeat as long as the inputs are not repeating. So yes, this is a function. Okay, so that is the third representation, which is a table. The last representation is a graph. Okay. Graphing seems to be the most simple because it doesn't really involve any math per se. So like, let's say we have a graph here, right? And then we plotted some points and then we came across this. Actually, you know what? I'm gonna start with something a little simpler. I'm gonna start with a simpler graph. So let's say I have the following graph and I created this line. Sorry guys, I'm all over the place. So let's say I created this and I drew a line. Yeah, okay. So the way that you can tell if this graph is a function or not is what we call the vertical line test. The vertical line test is when you take a vertical line, so in this case I'm using a pencil as my vertical line, and you run it through your graph. So I'm running it through, starting from the beginning of the graph, and I'm just gonna go straight across and I'm gonna run it through my graph and check to see how many times that green line hits my pencil at a time. So what I mean is I'm taking my gold pencil and I'm running it across the graph, and as you can see, at any point, my vertical line only touches my graph once. And so because it only touches it once at a time, it has passed the vertical line test. And so because it passed the vertical line test, it means that it is a function. Okay? So when it passes the vertical line test, it is a function. Let's try a different graph. Let's try a more challenging graph. So again, I have, let's say I come across a graph that looks like this. Okay? So in order for me to tell if my graph is a function or not, I'm going to use my vertical line test. And so this one's a little bit trickier. I want you to pay close attention to my pencil. So if I'm starting here and I'm rolling, only hitting it once, 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 once, all the way through until we get to the end of our graph. And so once again, it has passed the vertical, sorry, my dogs are going crazy. Vertical line test. It passed, so that means it is a function.